Let's go to that, please. Right, first thing first. Right, around the electric charge, right? Deviation already. Right, around the electric charge, we know that what exists? Electric field, right? And the strength of the electric field, right, is the force acting per unit charge. Right? I know we did this already, I just going over. Right? SI unit is Newton per coulomb or volts per meter. And very important, it is a what? It's a vector quantity. So we have to take direction into consideration, right? Right. Before we do any calculations, I want you to also remember that if I give you two parallel plates, is there electric field between them?
Yeah.
Yes. And the strength of that electric field is dependent on what? Distance and potential difference. Very good. Right? So electric field strength is given by P on D. Okay, just mark favor. Add those in place. Is that you?
Yeah.
Play now?
Yeah. Are you doing something? Yeah.
Yeah.
You're right. Okay.
No, I just go into go. Right? B is the potential difference and D is the separation between them. All right, nice. And then we also looked at right. We also looked at finding the force. We also looked at finding the force between two charges, right? And we said that the force was proportional to the product of the charges and proportional to the square of the separation. And then we came up with this nice little formula here.
Proportional.
F is equal to Q1 on Q2 all over 4 epsilon R squared. Right? And I gave you the value for epsilon, right? Yeah, 10 to the minus 12. All right. So that is where you find the force between two charges. You okay with that? All right. Yeah. Are you okay with that? Quick question. You can just do my favor and work out it. Work out 1 over 4 pi epsilon. I am going to call that quantity P. Yeah, just give it in the front, but in case you never see it in your life, I'm going to show you where it came from. By the way, all of these constants are saved in a calculator. Yeah. Casio. Huh? Serious. Okay, I got it. I'll show you. Check. Yeah. All those constants are there, right? So you don't have to go back to the front. Right? All the constants there, so you can use them. You have different epsilon. Epsilon, not it? Yeah, it's not yeah, it has the different epsilon. So the depth is epsilon. With the free space. Right. Anyway, K is what? K is what? I know it's a constant. What's the value? 8 point,
8.9 by 8.9.
okay, right? So you have that value as well. So instead of writing Q1 and Q2 all over 4 pi epsilon, you could also write K by Q1, Q2 on R squared. And K is this value here. All right, but I don't think that's in the calculator. Right, but you'll get in the formula sheet. Well, in the front of your basket.
Where's the value for K?
Hmm?
What's the value for K?
That's the main board. I don't know where wrong with this. K is 8.9. 8.9 by 10 to the 9. Huh? I don't have it, boy. This is already full screen. I'm sorry. 8.9 by 10 to the 9 now. All right. So we can also use, so far we have right, we have E is equal to F on Q, we have E is equal to B on D, we have F is equal to K by Q1, Q2 all over R squared. Now let's do my favor now. Suppose I wanted you now to find deviation, right? Suppose I want you to find electric field strength, right? Suppose I wanted to find the electric field strength here at distance D away from a charge Q. How are you doing now? Think about it. How are we going to do that? Yeah.
Last weekend?
No. Right, so watch this here. Right, I want to find some distance D away, the electric field strength from a charge Q. How are we doing that? Just right. So find for F, right? All we have to do is take F and place in here. And then what will happen? You will get K, Q1 and Q2 all on R squared. I want to find the electric, let's call that Q1. Electric field strength at Q1. So what will happen? Cancel. So you'll end up with K, Q2 all over R squared. It's in the under. It's in the
So yeah, you need to show it.
all right, so basically, here's the short. In short, in order for us to find it, it will be K over K by Q over R squared. All I did was I put this in here. Right? So if I have K, Q1, Q2 on R squared, that's F, and I divide it by Q. Right? Remember, it becomes multiplied. So one of the Q's will cancel. Why what?
Yeah.
This is F.
Oh, okay. Nice. So that's F is equal to K.
F is equal to K Q1. Right? So I took this F here and I substituted here. And I get this relationship here.
Okay, yeah.
So once I know Q, huh? Sorry. Let me do it slow up here. Well, E is equal to F divided by F is K Q1 Q2. I'm going to flip it over because it's divided. And one of the Q's will cancel.
And what we what we find with
No, and then make F the subject. And then substitute square and simplify. Right?
what we do.
Yeah, we're trying to find E, but in order to find E, I was showing you a different relationship that we can use, that we can use this and this. Right? So I need to get, I put this in there to get this one. This will work. Because I have Q and I have All right. So what we going? This. Yeah, no. So just write this. All right. So these are the things that we're going to use for a little while, right? So let's practice a few. I'm really sorry that I can't send you all the questions. All right. So number one. Let's start easy. A charge of 2 microcoulombs, but you need that to practice. Very short. Very short. A charge of 2 microcoulombs. A charge of 2. Ariane, what's going on with you, boy? Right just now. A charge of 2 microcoulombs is placed in space. A charge of 2 microcoulombs is placed in space. In space. Equals up. What is the electric field strength? What is the electric field strength? .5 meters away from the charge. What is the electric field strength? 0.5 meters away from charge. Right? So we have a charge. Did I say positive or negative? Positive. Positive 2 micro, right? Positive 2 micro. And I am at distance 0.5 meters away. I want that value E. Right? Nalia, how are we doing that?
No, take it. Send you got it.
Nalia, how are we doing that? How we getting the electric field strength 0.5 meters away from that charge? E is equal to? Yeah, but we do have V. KQ over R squared. R is separation. So R can work as D, yeah. R is this value here. What was K again? 8 point what? 8.9? 8.9 by 10 to the 9. And the charge we have here is what?
10 by 10.
2 by 10 to the minus 6. And the separation is 0.5 squared. How much is that? Hello, okay, why I use this? 7.12 by 10 to the power 4. 10 to the power 4. What's the SI unit again? What's the SI unit again?
Joules.
That's not energy, it's electric field strength. Let's go again. Next one. Yeah.
8.9.
Yeah, exact coordinate 8.89. If you use the exact.
Yeah.
That's not that's what I'm important.
So when you say example, you get 7.19.
Right, guess is 8.9, right? Use 8.9. I'm not seeing it. Oh, wait, it's in it.
The exact value again is 7.19. 7.19.
Yeah.
Let's go again. What is the force? Let's go again. What is the force? Oh, wait, sorry. Remember electric field strength is a vector. So I can't give you magnitude alone. What direction will it be acting in? Right? So always think about it, right? The direction of the electric field is the direction in which a positive charge, if placed at that point, will move. So if I place a positive charge here, how will it move? Okay? That's the direction of the electric field. That's okay? Towards me, right? Positive and positive will what, Shivish? I'll go this way. I'll repel, right? That's okay? So the direction of the electric field is to the right. Huh? This one regular, yeah. This one. Next one, let's go again. Huh? To the right, yeah. Next one. What is the force? What is the force? What is the force on a positive 1 microcoulomb? What is the force on a positive 1 microcoulomb charge? What is the force on a 1 microcoulomb charge in a field
What is the force?
also in a field of strength 5 by 10 to the 3 in a field of strength 5 by 10 to the 3 newtons per coulomb. 10 to the 3.
It might as well said.
Ready? Take your time, check and see what you have, check and see what you need to do. Huh?
Yeah, so I did not.
Right, ready? Shivish, what do you think, right? First formula, right? So what you end up with? F equal to E multiplied by Q. E is how much? What is E? 5 by 10 to the, and Q is what? Right? 1 by 10 to the minus 6. 5 by 10 to the minus 3 newtons. That's okay? One. Thank you. Malia, you okay with that? Ready for another one? After you have breathe. Yeah. Vinaya, you okay with this one? So, together we go and sign out Timothy, right? Together we go and sign out, right? This first question I gave you, I asked you to find the electric field strength 0.5 meters away from Q, right? And you said that the value was 7.12 by 10 to the 4 to the right. All okay with that? So just to complicate it a little bit, I'm going to put a net charge here. Right? I'm going to put a net charge here. We did like this. I do combine it all, right? I'm going to put a net charge here. And I'm going to ask you to find the electric field strength at that point, some distance away, due to the two charges. Right? So you find the electric field strength here due to this one, and then you're going to find the electric field strength due to this one. And then find the algebraic sum. That's okay? Huh?
Big question. I know you add a charge, but I have no idea, but like, I don't know the distance.
I know, I'm going to give you a proof. I just want to just think it
So that's the diagram for the question.
It will look something like that.
That you want.
You do your own thing.
Wait,
Right.
you-
Not. 2-point charges. Just take it. 2-point charges. Five microcoulombs and minus 3 microcoulombs. Point charges, 5 microcoulombs and minus 3 microcoulombs are placed 1 meter apart. Are placed 1 meter apart. First up, what is the electric field? What is the electric field halfway between them? What is the electric field strength, of course, halfway between them? Yeah, you did 8.9. Well, use the first time you stick into that, right? 8.2. Right, yes, direction's important. So when you find the field strength, make sure you put it in the right direction, right? So you will know if it carries a plus or a minus sign, right? When I have your other time, you what? Yeah. Yeah. Yeah.
2.8 by 10
I want to do that now. Yeah. Right, so it's in the middle, right? So that'll be 0.5 meters, 0.5 meters. Q1 is, what was the values again? Plus 5 microcoulombs, minus 3 microcoulombs. Right? So I'm going to find the electric field strength due to the positive charge first. Right? That will be K 8.9 by 10 to the 9 by Q. Right? Please notice that we're not writing the signs in, huh? Right? We're not writing the signs in, we just indicating the direction after, right? What's this again? Right, 5 by 10 to the minus 6 all over 0.5 squared. This will be a E plus, and because this is positive, it will go in that direction. Because this negative, it will also go in that direction. You're seeing that? It will be attracted here and it will be repulsed there. That's okay? So the two electric field strengths going in the same direction. Yeah? How much shall I get here?
178,000.
Give me the exponent. Okay, give me the exponent.
1.78 by 10 to the power 5.
Right? And this is acting to the right. That's okay? Ariane, you okay with that? Everybody get it?
Yeah.
Right? So this would have been for the positive 5, now the negative 2. Online, are you okay there? Negative 3, sorry. Negative 3. Huh? Why the positive going that way? Because if I place a positive charge here, how it will move? So what? So both. Because the positive charge on the left side, so they push it that way. So if I place a positive charge here, it will push it that way. So the electric field strength here going to the right. If I place a positive charge here, it will go towards the minus 3. So both of them in the same direction, right? So it means that I have to sum them up. Right, Divesh? I'm not sure about that. So remember, electric field strength. Remember, electric field strength is the direction a positive charge will move when placed at that point. So if I place it here, it will move to the right.
So I think people get confused because usually the negative charge will go towards.
Right, but so I don't want you to get confused. Think about a positive charge here, right? If I place a positive charge here now, with respect to this, it will go that way, right? But if I place a positive charge here with respect to this, it will also go
that way.
towards it.
So it's because we sum it up in the end and it's a positive in the end that will go towards the right.
No, it's going towards the right because the rule for direction of an electric field is the direction of positive charge will move in when placed at that point. So if I place a positive charge at that point, it will go towards the negative. Right? So it's not as a result. That's the rule. That's how you work out the directions of the fields.
So there's no there's a relation, the rule has a relation to the amount of charge each point has, right? So for example, if it was +3 and -5, it was same.
Direction wise, yeah.
Yeah.
But these bars will be different, right?
Right.
Right. Watch this here. I want to point out this. I am not writing -3. Right? I am not writing -3. I just want the magnitude in the formula. Right? So that's why a shot up it off. Some books you will see this modulus. Right? So you don't need the sign here. What's that? Oh, that's not us.
So negative value is a guide your way here. Eventually, if you have a negative value there, you're gonna add it.
No. That will confuse you. So ignoring negative. So why you go with the way you put it? Right. Right? Just now, what value is this?
Why would it?
Huh? 1.07 by 10. City?
Yeah.
So
Yeah.
it's just 3 changes, so it should be the same thing. Right. So let me explain this again. Electric field strength is a vector quantity, right? And its direction at a point is dependent on the direction a positive charge will move when placed at that point. All right. So if I have an electric, if I want to find the electric field strength here, and I have a positive charge here, right? Let's call that Q plus, right? The direction will be away from it, right? If on the other hand, I had a negative charge here, the direction at that point will be towards it. That's okay? Right? But now, if I wanted to find the electric field strength here, and I have a negative charge here, the direction for the electric field strength, not the direction of the force or anything, the direction of the electric field strength will be this way. Right? That's the direction of the electric field. Remember, electric fields always go towards the negative and away from positive, right? So the direction of the electric field will be towards the negative. That's why I have it here in the same direction. That's okay? Does that make any more sense? So you have to figure out what direction a positive charge will move at that point. Right? So why is that important? Right? Why is that important? What you here? The reason that's important is that the electric field strength at that point, right, is the sum of these two. So it will be 1.78 by 10 to the 5 plus 1.07 by 10 to the 5. If you made a mistake now and put the minus sign here, then it might again negative here, it might end up being wrong. Right? And the minus sign doesn't indicate a different direction because they both go in the same direction. Huh? Why a minus? Right? So exactly. So that is why I use the modulus. Guess the magnitude. Don't put the sign in electric field strength. We will work out direction based on the rule. Okay? That's why look at plenty books, you will see this modulus. Right? Yeah. Yeah. So the charge on the.
This is always the
That's fine. Was that yeah? Let me try and answer yours first. This
Yeah. It's only positive.
is always the okay. This positive simply means
The one, yeah, that one.
right. Yes, that's the rule. The rule is to find the direction of the electric field strength at any point is the direction that a positive charge will move in. So I just draw this positive charge to show you when I put a positive here, it will move that way. Right? If I wanted the electric field strength here, what direction will it move in? This way, yeah? Right? Because if I place a positive charge here, it will tell and go the next way. Yeah, Ryan? Huh? How come the? Right. All right. So what you're probably mixing up, right? What you're mixing up is there is nothing here. There is nothing here, right? If there were a positive charge, yes, it will come that way, but we're not interested in that. We are interested in finding the direction of the electric field strength at that point. Think about this. Let's think about it like this. If I actually draw the electric fields there, what do you do? And should do that? Right. So the electric field strength here, based on this, is to the right. I found it. The electric field strength based on this is also to the right. Right? So it's just direction. That's the reason why I put the positive charge there, but there's no positive charge there. That's just to help you find direction. Yeah, why? Huh? Yeah, the one I'm gonna give you now is yeah. Because it will go it will push it the next way. Right? Yeah, the pass.
In the event, right? Because when we have positive on Q1 and minus, or when we have positive on Q1 minus Q2, it will always go zero.
So like that or why you into the right?
Because of the position of the, if we have a positive line in the middle.
So to do the word or right? But yeah, like a positive charge here, negative charge here, also all we go in
Right,
that.
so the only way they're gonna go to the left is that this circumstance, if Q1 is a negative, as Q2 is a positive, right?
I'm gonna give you one on the yours. Yeah. Huh? Because the electric field strength due to this is this value. The electric field strength due to this is this value. And they both actually the same to the combination of both of them. It's a vector. Right? So it's dependent on, remember, this contributing electric field strength, this also contributing, and they contribute in the same direction. So I sum them up. Okay, total. Huh? Was listening all the time. How you find direction of electric field strength? Right? So the positive will go down. That's how you get direction. But there is no positive charge here that is helping get direction. How much is this? Let's go again with an exacting, right? Let's go again. Up. Let's go again. No, next one. Yeah, like it. Yeah, at the end of that particular.
Yeah.
Yes, no, you wanna have the next case. No. That's good. Right, a 1 microcoulomb charge. Sorry, that's the wrong one. No, but we can use the same bar.
Oh. There was that. Look at this, look, I want some later, but. We have like a.
Alright, try this here. 2-point charges. Yes. Yeah, recording the class here. 2-point charges, one positive 1 microcoulomb. And positive 2 microcoulombs.
Oh gosh. So you're real fast and after
2-point charges. 2-point charge, making sure I've typed this up for the next time, right?
Yeah.
2-point charges, 1 microcoulomb and 2 microcoulombs are placed 2 meters apart. Are placed 2 meters apart. What is the electric field strength? What is the electric field strength at a point? I'll leave it halfway, right? Halfway between them. What is the electric field strength at a point halfway between them? 1 microcoulomb and positive, 1 and positive 2. Take your time. Same steps, right? Same steps. And just change the values a little bit, right? Right, they're both positive, right? That's 1 microcoulomb. I'm not going to undo it, I'm just writing it here. You have time. Online, take your time, message your answer.
Yeah. And the plus minus. And one
Make sure you pick up like it, or something, huh?
Which one is starting?
I don't want to copy like training class and we had a cancel. Ready?
Yeah.
Ready? Right, that again, direction important. Let me see. Nalia. What direction will the electric field strength be due to this? West. So, right, and electric field strength due to this. So in this example, when we get the values, what we doing? We're going on minus them. All right. So you'll get 8.9 by 10 to the 9 by how much is that?
8.9,
Right, and when you work out this, so that'll be twice that, right?
Yeah,
How much is that?
1.7 by 10
By 10 cities. Now we, right, because it's a vector quantity, it will be 8.9 by 10 to the 3 minus 1.78 by 10 to the 4. The minus indicating that it goes to the left, right? That's all, right? How much is this?
Yeah. Minus 8.9 by 10 to the 3.
All right.
Sis,
yeah.
Right, what does the minus indicate?
yeah,
To the left.
8.9, not 8.9.
Well,
Huh?
8.9.
Are you okay with that?
um,
So suppose I want to make it harder.
especially we can harder, right?
Yeah.
I will go with side of penny, two or penny one.
How you side the muscle.
So
Based on my diagram, that's how I
So
am.
you can put, so 8.9 positive backward, right?
positive.
And based on your diagram, right?
Positive, correct, so you can see the right.
Based on what you get. Right, but that's a good point. Here what you can do, right? 8.9 towards 8.9 towards the 1 microcoulomb. Right? So you can write this. All of us should get this. Right? Nikolai? So if you use your diagram, you should still get towards the 1 microcoulomb.
Yeah.
So if you switch it, it's towards the 1 micro, right? So the better thing to do is to write up. Right, so I want to make it a little bit harder. What to do? Before adding a third force,
Right.
which is what?
You put like
Change the, right? I can change the distance, or here what I can ask. Here's what I can ask. I would like to know where is the electric field strength? What does that mean? Think about it. Right, these two have to be equal, right? So if I ask you, where is the electric field strength 0? These two have to be equal, right? And then you add it into something like that. Right? Let's go again. Are you okay with this one now? Online, Shania?
No, you can't go now. You can't. No.
Yeah, you okay?
You.
Alright, let's go again.
Everybody goes now. You could, but you say exactly.
2-point charges. Let's go again. Take your time when you're solving it, right, Olya? A little more max, I think it'll get constructed, right? Take your time. A little more max involved here, right? Alright, 2-point charges are placed. No, sir. 2-point charges are placed on the x-axis. On the x-axis. No, same principle, let's give it a bar. On the x-axis. Hold on. 3 microcoulombs at x equals to 0. 3 microcoulombs at the origin, basically. Right? 3 microcoulombs at the origin and minus 6 microcoulombs and minus 6 and minus 6 microcoulomb at x equal to 1 meter. At x equal to 1 meter. Full stop. Find the position along the x-axis where the electric field strength is 0. Where the electric field strength is 0. Yeah, so basically, yeah, the 1 meter path, right? Yeah, I think so. I think yeah. Right? So Nalia, since you're looking lost there. Right? We have one charge here and a next charge here. Correct? So somewhere in the middle here, the electric field strength should be 0. Right? We don't know where it is. Let's pretend this here. What's the distance between two of them? 1, right? So how much is here to here? You don't know. So what you put if you don't know? X.
Not only one.
And what you put here then?
Z.
Huh?
5.
Two of them can be X. The 9 in the middle.
Z. X1, X2.
All here to here is how much?
1.
Here to here is?
1 minus X.
So here to here is 1 minus X. Right?
Oh, that's how we're going to take care of it. That's also.
Okay? Go ahead. Have fun. Nalia.
Really 0. I get that.
Take your time and solve this, right?
It's not really spreadsheet, that just is show. Yeah, but you want to do it. Show. Now, get ready for this. It was very last ago.
All okay? What did here? Huh? It's somewhere in between, right? So we just make up position B. Go ahead. Solve it fast. Huh? Yeah, we know what K is in the solve fact. Solve in fact. When I ended it distance, so that'll be R. So this will be R, this will be R.
Oh, got it. These are the operators. Now I see my lady, say what is right up here. And she's out, and she's out by
Inline by the traffic light.
yeah.
Everybody there?
Yeah.
Yeah.
You like it?
What kind of name?
Check TV inside, we go inside, check too.
Oh, yeah. Sounds bad. One of the best. Anyone? What do you want to put here? Plus 6. What's the next one? 6 on what? 6 on 3 on -6. Right? Doesn't matter. 2 as x without the matter. That's a vote. Find equation and then equate them. X as on. That is. This way we get just a fast equation. Right, so, oh, sorry, it's not E is 0, eh? E is equal.
Yeah.
Right, you know, I do like so, right? This is x squared. This is 8.9 by 10 to the 9. And I'm using the modulus here, so that'll be 3 by 10 to the -6, right? Always using modulus. For this for electric field strength. Those are the right? But for electric potential, you'll need it, right?
Yeah.
Or right now, the electric field strength.
Big values of.
No, it had to be a value here, but less than 1.
Oh, yeah, so because I think.
So when you reach here, right, and next one is what? The next one will be 8.89 by 10 to the 9 by the next value, which is 6 by 10 to the -6 all over 1 minus x all squared. This will cancel, so there's no need to work with that. This will cancel here, and I'm just trying to make it a little bit easier, right? So we'll end up with 3 on x squared here.
Wait, that's not divide by both sides.
If I bring this here, copy, they will cancel. If I bring this,
Oh, yeah, these two letters.
right?
Oh, you know.
If I bring this here, it'll cancel off.
I am multiply them and I carry it across.
So technically, that's what it will give it. Right? This will cancel.
That question, right?
Okay, divide both sides by 8.9 by 10 to the 9, and that will cancel. Right? And divide both sides by 10 to the 6, and that will cancel. And then turn it into a quadratic and work it out. Yeah?
What if I multiply it out, right? And I cross multiply. So I get 200, I get 6,700 squared.
You get real numbers? I get high.
Don't worry, we will help you about it. I do not.
6 I'm pretty sure. Bye.
Yes, sir, why?
Okay, then they would have complained on the back. So I just leave one out.
Yeah,
Right?
we have to do that.
They would have complained and say, well, how I get it. So I just wanted to work it out, right?
Yeah.
Right? So you'll get quadratic looking like this, right? And you get x to be what?
0.1.
0.41. So I get it? I cancel this and this.
My pass that.
I cancel the units. So I cancel it. It can be the 6, can be the 6. So that's the 3 and the 6 are in the margin. is cancelled. I think on the three of them. Any questions online earlier? Online, any questions? Anthony? Pooja? You're getting to? Kavisha? Right? So the answer is 0.414 from the 3 microcoulombs. Yeah?
Yeah, that's how we got that. That's how we got that.
I expanded across multiple.
Yeah, I got I think you'll better understand if you actually translate one.
Wait, why do you understand? I expanded.
And then you multiply by.
By three, yeah.
Yeah?
So, but I never would have been simple if it does. Cancel it.
When I cancel this and I write this, what is simple? Nobody see it. Right? But it don't matter. That's what it is. Right? But yeah, you can cancel it too then. I don't want to do too much cancel and I get lost. Trouble? Next area. You okay? Nalia. You okay with this? Yeah. Right? So therefore your answer is 0.414 from the 3 microcoulomb, right? George, you okay with that? Yeah. Let's go again. I'll give you a drink after that, right? How? Yeah.
Yeah.
Right? And that's cross multiplying, right?
Yeah.
No, this area. I just cross multiply, right? So if I bring K up cross here, then I'll cancel off. Right? And if it were well, I didn't write the units. But if I carry this across here, and I will get 6 and 3, and the unit to cancel.
I did that cancel the 6 and 3, you cancel it.
Area. If I move this across here, and it will be 6 by, and it will be 6 by 10 to this minus 6 all over. It's to cancel and you'll get 2.
Yeah.
Right? That's all I did. I canceled this early. Right? So I just divide both sides by 10 to the 6. Yeah, you carry the negative value for it. One more, I'll give you a break. One more, you'll get 10 minutes. All right, 2-point charges. Last one, I'll give you a quick, right? When I combine something again. 2-point charges are fixed in a place. This one. 2-point charges are fixed in place along the x-axis. 2-point charges are fixed in place along the x-axis. A charge Q1. A charge Q1 a charge Q1 of 5 microcoulombs. A charge Q1 of 5 microcoulombs is located at x is equal to 0. It's located at x is equal to 0. First up, a charge Q2 a charge Q2 minus 3 microcoulombs is located at x is equal to 2 meters. Is located at x is equal to 2 meters. Part 1. Part 1. Calculate the distance between them. Calculate the distance between them. Where the electric field strengths are equal. Where the electric field strengths are equal. Try that fast. Yeah,
Right, so after part 2.
I'll give you that after. We'll go that fast. That's what I'm thinking. Yeah.
Could be, could X and X Y, that's gonna be anyone, any side.
Huh?
X and X Y, that's gonna be any side. And how you have.
Yeah. That's why the final answer is where x is. Because the final answer tells you how far away from a particular point it is. Take your time, same principle as before. Should be simple.
Halfway we don't know what the.
And by ignore the sign in this calculation. I take your time and solve it. Let's start to say this time more. Yeah, I got a question. I'll give all, listen to all of them. Right, let's see how they go in here online, commission them, okay, it's another answer, right? Commission, if it's just another answer, I want to take a look at it. Kyra. Kyra. Thank you. Okay. Round. Yeah.
That's what
Yeah, and you're getting email?
I never got email.
Check on the email.
Right? How are you?
Okay. You also fill out in Google form. Once it fill out in Google form,
So are you?
yeah. And then they'll put the. Yeah. Right, let's do one here now. Let's see what happened here, right? What the balance again? What the balance again, Olia?
Final.
Any distance to meet the.
Right, so x and 2 minus x, right? So you want the electric field somewhere there where it's equal. So that will be k by 5 by 10 to the minus 6 all over x squared is equal to k by 3 by 10 to the minus 6 all over 2 minus x squared. Same thing, k will cancel, the units will cancel, and you'll get 5 on x squared is equal to 3 over. Right, I'll expand this one time. 2 minus x all squared is 4 plus x squared minus 4x. Right? I'm killing. Then you cross multiply. So you'll get 3x squared. 5 by 4 is 20. 5 by x squared is 5x squared. 5 by minus 4 is minus 20. Bring everything here. And I will get 2x squared minus 20x plus 20 is 0. What I got for x?
1.13.
Same equation?
Yeah.
1 point.
One
Right? What I did wrong?
I think the opposite. So you see, you have 3 or 4 plus, that's really a high. I had to put my extra.
For this one?
The second number is 2 values from quadratic, so you use the second one of p. And then our next one is put p equals sign again.
That is looking imaginary, though. Huh? Anyway, but that's the way it generally work it out, right? Probably I'll make it up on the value a little too small. Huh? First x value again. Part 2. Part 2 to this, right? Right, but you're on the principle, making them equal and working, I can break up. Got it?
Yeah.
Right back. Last one. Huh? Last one. Part 2. Part 1 was to find where it writes. Part 2, and I'm stopping there. A third charge Q3. A third charge Q3 2 microcoulombs, sorry, positive 2. A third charge Q3 positive 2 microcoulombs is placed at x is equal to 1 meter. Between Q1 and Q3. Between Q1 and Q3. Well, midway, right? Midway between Q1 and Q3.
Yeah.
Right, to this part, they wanted to find the net electric field at Q3. Find the net electric field at Q3. Right, the hint is you don't need the charge Q3 as yet. Okay, you just want the net at Q3 due to Q1 and Q2. All right. Oh, yeah, last part. After this. All is the same question, but then I give you 5 minutes.
I'm good for 5 minutes. So this question take me 6 minutes. So how long for this question in this video?
Like it's whole thing,
Yeah.
it's like a whole question, 10-15 marks. Okay, the values. All Q1 again, 5.
Yeah.
And Q3 was one. Positive. Right, so the one the electric field strength here. The electric field strength here due to what? Is gravity there? Take a little break now. Take a little break. It's due to what? It's due to Q1 and
Q2.
right? Right, so find the electric field strength due to Q1 and Q2. We're doing it with this distance and this. Oh, anyway, distance. No, you don't need Q3 as yet. You need Q3 for the last part I'm going to give you. No, one more. Why give it Q3 then? One more. You don't need Q3 right now. Right, the one the electric field strength at that point. Nalia, what direction the electric field strength acting on based on this? And based on this. So both of them are so. Yeah. Go ahead. No, electric field strength.
So we just care about Q1.
Yes, we just can about this.
So it's like Q2 right there.
Okay. That's our group. Right, just one little piece after and we are done. No, we're done giving a break. We're done to get a break. To continue. Wow. It's we're supposed to finish last. How we yeah. Behind my camera.
Yeah.
I got 1.7. That's what I'm part of, sir. That's what I'm part of.
Right.
Your production.
So she's not, no, she's not.
Right, try that quick. And those who done the last part, they could find the fourth exercise on Q3. That's the last part.
I get 1.7 this. I said, these are polarities.
Huh?
A small value.
Okay.
Yeah, 1 point something, but it's supposed to be larger because. Look at it.
When I'm done, yeah.
I guess if you look. Yeah. Well, you take it, you take it.
How much you get here? How much you get here?
4.45 by times 3.
4.45 by. Okay.
By times 4.
Right, yeah, you just want to be here.
And that one is 2.67 by 24. So I just added that.
What? I guess 7.1.
You did that.
How much?
What's your book like?
Right, last part. Last part, Vinay. Yeah. Part 3, Vinay.
No, you was
Right? Part 3. How we getting the force in it? Huh? Of course, which formula are you gonna find? How you finding the force exerted on the charge? And you just found the electric field strength right there.
F is equal to K Q1 Q2.
F is equal to E. Right? Electric field strength, sorry. Electric field strength by charge. Right? So that's the way you find the electric field strength. And the charge is 2 by 10 to the. Right. Right, so when you're done, you get a 5 minutes. For extra 5 minutes, I'm willing to give you an extra 5 minutes.
Yeah, I'll take that.
What is the next method I could use to find it? That's not. Take your time, one answer. If you get it wrong, you're minus in 5 minutes.
Oh, God.
Take your time, one answer. How much you got here?
Yeah.
1, 4, 2, 4. Huh? 0.14. Online, produce the escalate, okay? Right, so to find the force, I use the electric field strength, right, that I found here, and I multiplied it by the charge, right? That's why I give you the charge. But there's a next thing that we could do in order to find the force.
Yes, sir.
Right, come here.
Yeah,
This is the 5 minutes, huh?
Hold on, yeah.
There's a next technique that we can use to find the force. Huh? Yeah, it's something to do with something I give you. Anybody can answer. Alright, I'll give it 2 chances. Right, yeah. Go first. But you can't do it now. Find F just once.
Plus the balance.
Yeah,
Twice, they use the 5 and the like the 3 so
Yes, okay.
Very good.
right.
Right?
Give them 5 minutes.
Watch it here. So you can use Coulomb's law and find the force exerted by this on this, and then find the force exerted by this on this, and then find the result. Right? That's why I'm moving on to after quick, right? Right, take 7 minutes.
5 plus 5 is that.
Oh, yeah, 10 minutes, 10 minutes. Right, those who go on the break, we'll call this the long way. Okay, we go on the break. Oh yeah, 10 minutes and then we stop, right? Online 10 minutes. Alright, next, right, so here's what we're doing now. We continue with the same thing, right? So we wanna try to find the force exerted on the we wanna find the force exerted on Q3 method 2. Right? We wanna find the difference between, now, right? So let's see if we could do that. Right, method 2. So quickly, what direction now we're dealing with the force, right? Nalia, you do this man. There's a positive charge. There's a positive charge. What direction will the force be in on this charge? Push it away, right? So that's the force called F1. What about the force exerted by this charge? Attract as well, right? That's attracting it. Right? Because there's a positive charge, it will go that way. So both F1 and F2 in that direction. All right? To find F. All right? So to find F, we're using what again? Nikila? What is the formula we're using to find F? Q1 over, well, I'm using K, right? K by Q1 and Q2 all over R squared. All right, so we will end up with 8. So I'm finding F1, 8 by 9, sorry, 8.9 by 10 to the 9 by Q1. Q1 is 5 microcoulombs. And Q2 is 2 microcoulombs. All right, and then you're dividing it by their separation, which is 1 squared. How much is that? 0.13.
But then F is supposed to be equal, so F is supposed to be equal.
Yeah, but it's F1 alone. So
Oh,
now I have to find it due to next one. That's okay. So I found the force. I found the force due to this one. Now I'm gonna find the force due to this one. Okay. So it should be close. Mightn't be the exact thing. So that would be 8.8. Sorry.
Wait, I have to interrupt you.
0 point. Arian, come stand up here. Right. Anybody else besides Arian? What is this? Anybody else, right? What going on? Going on? So I find it, I find the force on this due to this, and the force on this due to this. How much you got? Just come out. 0.534. Right, so therefore F is equal to F1 plus F2, which is 0.089 plus 0.0534. How much is that? Right, so we got to go. That's okay. So there are 2 ways for us to find the force exerted on a charge.
Would you say that how the set belong is more accurate?
Would I say the long? No, because this is not longer, you know. The reason it's longer is because you're ignoring this. But we have to find this first, the electric field strength. Right, so it's same thing. Without the electric field strength, we couldn't find the force.
But with that,
It had 0.24 here. Yeah. To make you happy, right? Right, you understand what went on here? Right? So I found the force exerted on this by finding the electric field strength and then multiplying it by the charge. And I also found the force here by using Coulomb's law twice. That's okay? Okay. You get that?
Yeah.
Correct.
That's right. But I still understood. You are guys. Well, I guess not before you. That's sleeping with you.
Ready? Let's go again. Thank you. Oh wait, where's some of your people lobby?
I'm too excited not to come to class.
Sure, let's go.
No.
Hey, so any course competition?
Oh, so I don't have all the rooms this week and next week, right? But do the following week, now we good? That's the
You want to
week.
do tomorrow?
No, I don't have the best and this, all the rooms this week and next week.
What is it?
Huh?
19.
19.
Alright, get out there.
Back it was?
Yeah.
Okay, good, so I'll send all the rooms, right? Yes, ma'am.
I didn't feel my students invited. Wait. I didn't feel my students invited yet, so no. Okay, well then.
All right, next one. Next one. Find the force exerted. Find the force exerted. Right? Find the force exerted on Q3. Right? Find the force exerted on Q3. Right? Given the following values, right? Pardon me.
So what? I said, what is?
Right? Find the result on or find the force exerted on the 2 microcoulomb force there, right? Q3. Right? Find the resultant force on Q3. Right? Shavish, you'll be able to guide me along like what you do? Shavish. How are you going to find the force exerted on Q3? What exerted the force on Q3? Q2, right? And Q2 exerting a force in what direction? Down? Why? right? So this will be pulled downwards, right? And there's a positive charge to push it away. Right? So you'll end up with something like this. Yeah? So the force exerted by Q2 pulling it down. The force exerted by Q1 pushing it to the left. How are we getting the resultant force after Soraya? We're going to minus that. Find the result. Yes, Ariane?
Yeah.
Find the resultant force using
Pythagoras theorem.
Pythagoras theorem. Okay? Go ahead, hurry up. We have one more to do after.
What?
One more. Faster? Online, anybody paying attention, sir? Anthony, yes, sir? Was this four, right?
No, why not? He didn't know. It was the closest one. He didn't hear.
158.
Yeah. It was one side. It was one side. It was. Yeah. But if you want that ship, you'll get that.
155. Finally, force exerted on the two micro on the
Twice.
You want something?
It's not a price for price.
It's like, I want to see exactly what.
They don't want to sound to it. It's just like I didn't want like it there. I just changed where it was down. I mean where it charged it down. After, yeah, that's after. This was easy, you could have found it, but look at where it forces down.
You can't see it. Like, I can't just rewrite it the way that keeps the same answer.
Having a different now, because of course, so I can different direction. But you're doing the same calculation, like this, yes, when you reach the last step, in the high, which is a minus cent. So you can find out. You don't have to. Pythagoras is what? It's square. Finish it. Last thing I'll be done. Tomorrow. Where does? Well, you can just multiply and add all the words. Just multiply and add the things that we did today. Right, that's a key. You know, see exactly. You want to do it, I come to do it for you. Yeah, all you gotta do is just drop in some value. That's it.
Oh, I should.
Sorry, so.
Anybody got 0.0534? So the resultant force is what?
0.233 square.
Plus the other one squared, right?
Yeah. I get now 0.057, 0.054.
Yeah, but you get your own thoughts. It's sinus five. You press three and.
See, I'm sure it's here, right? Okay, you got it? Right. The separation is 2, right? And the separation is 2, right? That's it. Right, this one was similar to our past paper, just taking up on, right? Right? Number 2. I'm not giving you any values, you just have to understand the concept. If the distance between two charges is doubled, if the distance between two charges is doubled, what will happen to the force? Right, write it down. If the distance between two charges is doubled, Push the bell, or you just push the bell.
Yeah.
Okay, five.
Yeah. Yeah, shout out, sir. Yeah.
Right, so I told him now there was something.
Sir, it's not bad.
I wish there were.
What? Not Josh, Franklin is someone else.
Sure.
Yeah.
So if the distance is double the what was amplitude force, right? Same charges. What happens if it double the force?
Yeah, the life force.
What you got? Huh? Huh? It divided by 4, yeah, correct. Because the formula is F is equal to Q1, Q2, K by R squared. So if R is half, you'll end up, sorry, if R is double. It will be Q1, Q2 by 2R all squared. When you square this, you'll get Q1, Q2 all over 4R squared. Right, so the force will be quarter. Right? One, two. Right, watch. If it's square, they said the distance between it double, right? So if it double it, when you square that, you'll get up. Right? What I say? Sure. Sure. Last one. Huh? I'm supposed to show you one thing, but I didn't show you. Last question. This is for Nalia. Sorry, Nalia. You ready? Last one. Please don't say the answer. Write a solution, 2 lines long, and we're done. I'll pass around and watch everybody and I'll sign and they get go. So that. Last question. You okay with this, Tibesh? You sure? 4 identical point charges. 4 identical point charges. Who said that? Four identical point charges of 5 microcoulombs. 4 identical point charges of 5 microcoulombs are placed at the 4 corners of a square. With the side length 1 meter. 4 identical point charges of 5 microcoulombs are placed at the 4 corners of a square with each side being 1 meter. Each side being 1 meter. What is the magnitude of the force exerted What is the magnitude of the force exerted at a charge at the center of the square? What is the magnitude of the force exerted on a charge at the center of the square? And last part was the magnitude of the net electric field strength. Find the magnitude of the net electric field strength at the center.
Say that again, thank you. If I should have to help,
Huh?
if I should have to get it.
Ah, you gotta figure this out.
Okay.
Huh? Not yet, no. Write it down 2 lines up.
Okay,
Huh?
keep looking.
The whatever you need, 2 lines long. Think about it as a square. Have a charge in the middle. What's the electric field strength on that charge and what's the force on that charge? But he wasn't it. And because of that, you're going to get next one for saying the wrong thing.
I want to hear.
Put it one first.
Right? Remember, it's a square, right? Like a part of the square?
So, like a bus.
Like a pass. Right, let's go. Who explained this one? Dipanshu. Dipanshu, what do you think? What will be the resultant force on that charge?
Seem to be calculated for the.
Vanilla valve. I don't know what to do. I just need a valve.
Resultant force of.
On cue. Think about it, Anthony. What do you think? All right, close. Close, but easier than not. Anybody? Nikolai, why is it your answer? Yeah. And all are the same force, all are the same,
Like,
all are the same, right? So, huh?
like it's something this square, right? And the other is a figure.
Right,
So it's 4 meters, right? So we find the color and find, you know.
so you find the force due to this one first,
Yeah. No,
so,
yeah, the parallel between this side. Yeah, yeah.
so let's just say this positive, right? What will be the direction of the flow between 2 of them? Upwards and? What about between these 2?
But that was,
Are they equal?
yeah.
Why are they not equal? And it's the same charges and same distance? What about here? And here? So the force is what? 0. That's why. Right? And if the force is 0, the electric field strength is? Right? 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 You notice I didn't give you a ball to work out, right? Here. So all you have to do is work it out this direction, work it out in this direction, and then here and here. And you'll recognize that they're equal. And why else? Alright? So that's it there. Next day, we have to do electric